Our project title is Housing Price Prediction. We majorly select three typical machine learning algorithms and compare their performance on two different datasets. Before we feed the data into the models, we need data cleaning. I am Wu Xiaoyin, and I will introduce my work of data cleaning from four aspects. Since the first dataset we use is too simple, I will just focus on the data mining part of the second dataset. The first aspect, benefit. Data preprocessing is important for most practical ML applications. It helps us to learn more about the data in a more intuitive way. Also, it helps us to get clean data with training and lays the solid foundation for further model training. The second aspect, we can understand data through statistical information, data visualization, and association analysis. Statistical information helps us to know numerical distribution of our data, including how many vacancies there are in the datasets, and also about median, max, mean values, and etc. Also, data visualization is helpful. We use scatters, plots, histograms, etc. to promote the understanding of data. Also, it is worth mentioning that human brain is actually very good at discovering the rules in pictures, but we need to use some tricks. Next, association analysis. We find that combining some original features using some simple formats provides stronger correlation between new features and labels. The third aspect deals with numerical features. Firstly, we solve the problem of non-values by inserting median values into the vacancies. Secondly, we remove outliers in the dataset to eliminate the noise. Thirdly, we create some new features and remove the old ones in order to better extract information. For example, we divide total bedrooms by total rooms and get bedrooms per room. We replace the old one features with the new one because the new feature has a stronger correlation with our label, median house value. Now, it comes to the fourth aspect, deal with non-numerical features. Since computers cannot understand text directly, we need to convert the text into a computer understandable form, numbers. However, converting it to several different numbers is too simple. ML algorithms tend to think that two adjacent values are more similar than two distant values. This is wrong, so we use the one hot code instead. Now, we have finished the data cleaning part of our work, and in the next part, my teammate will introduce more about the machine learning models that we use.
Linear regression to do the housing price prediction and to explore the problem about validation, underfitting, and overfitting. I will give a brief introduction about the conception, and then I will show you the programming. For the regression model, the workflow is as followed. There is an input vector x, which represents some features, and send these features into the regression model. After doing the computation, we can get a predicted value y. Because in regression problem, the linear regression is widely used, so I will give a brief introduction about the linear regression. The linear regression is a supervised algorithm that learns from a set of training samples and give output value y. In the housing price prediction, the vector x represents the house attributes and the y represents the house price. The linear regression is a popular method, but is restricted to estimate linear model. So if the vectors x is nonlinear, the linear regression will have a very bad prediction like this. And as for The price prediction, with multiple variables, is bounded to be a nonlinear program. So we adapt the polynomial regression to solve it. The relationship between a set of variables is multiplied as a nth order polynomial. The algorithm is as follows. We can add powers of each features as a new feature, and mapping higher dimensional x to be one dimensional x, and then we can use the linear regression algorithm to do the computation. And now let's see the programming. First, I used the pipeline to build a workflow. The first layer is to do the standard scalar to transfer the input data into a standard ones. And the second layer is to do the features transformation, mapping the features into a polynomial feature. After doing that, we can use the linear regression to do the final computation. The parameter polo is to set the polynomial degree to between 1 to 6. Then I use the split function to split the input data to train dataset and the test dataset. Now let's see the function. The first function is a preprocessing function which has to be done by the first person in our group. Now let's see the model function. I used the grid search to find the best solution. The CV equals 3 means I used the 3 cross validation, and the variables equals R2 means our evaluation is determined by R2 score. And I set the refine equals to true, which means I can get the best value function to put the data into the workflow. And this function is to do the format processing. And I use the mean score to do the sort, and I give the best the results to the estimator, because the amount of data is quite small, so I used the cross validation in order to get a better result. First, I normalize the data and do the k-fold cross validation, and finally, I can get the CV scores and the predicted value y, and the following programming I used to display the results like this. And when I run the models, that's the results.
uh, R square value equals 0.75, which is close to 1. So we can see this model is good for now. Decision tree. Decision tree breaks down the dataset into smaller subsets, while at the same time an associated decision tree is developed here. The tree consists of two kinds of nodes, decision nodes and leaf nodes. Outlook is a decision node, and it has three branches: sunny, overcast, and rainy. These branches represent values for the attributes attested. Orange nodes are leaf nodes. These values are our prediction. The decision-making process starts from the root node and partitions the samples with labels. In order to split nodes, we need to find the best feature G and its corresponding threshold Tm, and then divide the input space into two parts, Q left and Q right, and finally repeat this operation to build our tree. To select the best parameters, we minimize the impurity of nodes, G of Q and theta, which is computed with an impurity function h here, and this is the impurity function. Through experiment, we find that the best value of max depth of decision tree is E.
The neural network to do the housing price prediction. First, I will introduce the background. As deep learning is a subfield of machine learning concerned with algorithms by the structure and functions of brain called artificial neural networks, so it can benefit from big data better than traditional machine learning algorithms. The core function I use here is as follows. First, I use rectified linear unit activation function for building the model. Second, I use a K for cross validation. And third, I use R-score value to detect whether the result is better or worse. I'll briefly introduce my steps. First, I do the normalization. Second, I build the network to process the data. Finally, I plot the error value and the R-score value. Then I will show you the code. Like here, I first load the pre-processed dataset into the program. Second, I do the normalization to make sure that all types of data have a uniform format. I calculate the mean value of each kind of data, and then subtract the mean value from each data instance and divide it by the standard deviation of the data. Then I will build the networks to process the data. Basically, we use two middle layers, 64 nodes in each layer, but we only need to predict one result, so there's no activation function in this node here. Then I use K for cross-validation, which means divide the training data into two groups, one for training network and the other for verifying the training results. And here I print the predict test y. I also use the smooth way to smooth the data, repeat bit, and print the error value here. And then I compute the R-score as model choice and evaluation value and do the print, like here. Now show the result. The first error result is like here, like the more app codes. The error will just be small. Here is are scored values. Then I will do the conclusion. Firstly, we use the full models to train the first dataset, which is a simple one, by comparing the best R2 score of each model. We can see from the table, as for a simple dataset, all of the models work quite well, especially the tree model is the best one for this dataset, but the neural work is the worst. And we can just speculate the reasons as follows. Firstly, in the first dataset, the amount of data is quite small, so it is hard to take the advantage of the neural work, as neural works usually have obvious advantages when processing large amounts of data. Because in our project, the housing price prediction, it is very hard to define which values in the dataset are outliers. And in the neural work, we just use the L1, L2 norm to optimize the model. So, the existence of the mass outliers can make a very bad impact on the model. But for the traditional models like polynomial regression, KNN tree, all of which are using R2 score to do the optimization, so these models have more resistance to the bad effects about layers. Secondly, so we just do the prediction using polynomial regression, KNN, and tree by comparing the best R2 score of each model. And we can see here, all the models are not work very well on this dataset. We find out the main reason is that the second dataset has more data and more features, which means this dataset also has more outliers, which has a bad effect on this model. So, what we should do in our future works. With more exposure on this housing price prediction, we find more parts we need to do. The core one is that the outliers caused all our models to work poorly. So we need to do work on the data pre-progressing and refine our model to become more robust, which would possibly be our next step into this research. Thank you.